Hello, welcome back. Today we're going to do some integration of the inverse trig functions. Okay, I've just written these guys here. These are all the ones we know from differentiating. The first line here is all your basic ones. The derivative of inverse sine x is 1 on 1 minus. Cos is the same, but it's a minus, and tan is a little bit different. For the proofs of those, just go back to the previous video. I've also included a couple of different forms here, okay? This one in here, the middle row, I've just put that in there because it's kind of common and it pops up every now and then. Okay, notice here that tan is a little bit different. It's got a on a squared plus x squared. And if you want, just go through that and do a little proof for yourself. Just a bit of algebraic manipulation there. I've then also put this on with the functions in here, and we can do that using the chain rule, again seen in previous videos. Okay, so that lets us just go backwards and integrate. So we take, that's the derivative of that, then I can say that the integral of that is that, and so on. Okay, so these are all the integrals that we're going to use today. You'll notice that I just want to draw your attention to sine and cosine, the inverse functions anyway. These guys here, bit of a lag, these guys here are awfully similar. Okay, so I mean, if I want to integrate something like this, if there's no minus there, I could put a minus in and it's cos, or I could just take a minus out and it's sine. Okay, not that huge deal. Okay, so let's just jump into it and we'll do some examples. We want to look for these forms here so we can integrate it. And this could be a sine or a cos, couldn't it? But sine seems to me a little bit easier. What I mean by it could be a sine or a cos, I could put a minus there and then a minus there, and it would be cosine, but I'm not going to do that because it's silly. Here we can just jump straight to the answer, and we'll go, well, this guy here equals sine inverse x from 1/2 to 0. I know that sine inverse, I'll write it right out the whole thing, sine inverse 1/2, and then I want to minus off sine inverse 0. Sine inverse 1/2, which angle has a sine of 1/2? That's going to be pi on 6, and then sine, which angle has a sine of 0, and that's going to be 0. And my answer is going to be pi on 6. Okay, okie dokie. So with this example here, it's gonna be tan something. Okay, there's no square root. I've got something plus something x squared, and they look like squared things. So it kind of looks like this middle one here. Okay, so it's gonna be a little bit tricky, but it's just like taking numbers out and all that. Okay, so I'm going to take that 6 out first. 6, so I get a 1 on top, and then I get 49 plus 25x squared. Now I want this to look like that guy. Okay, so I'm going to take that 25 out. 6 on 25. Integral of 1 on 49 on 25, because I've taken the 25 out. Okay, that's what this is. And now, sorry, I've still got a dx everywhere, by the way. Dx, dx. Now I want my a on top. If that's a squared, a is 7 on 5. So I'll just do it on this line here. Okay, 7 on 5. If I times by 7 on 5, in order to keep everything even, I've got to times by 5 on 7. Now, I'll do one little extra step here, just in this example. So that's 5's will cancel there. That's 6 on 35 times the integral of 7 on 5 on 7 on 5 squared plus x squared dx. Okay. I've just written that out so we can clearly see the a's. And that'll just lag a little bit. dx. Okay, now I've got it in this form here. That means the integral of that, and I forgot my dx there. Apologies. Let's chuck that in now. The dx, the integral of that is x on a. My a here is 7 on 5. That means my integral will be 6 on 35. If a is 7 on 5, x on a is 5 on 7. And then plus the c. Okay. Let's come down to this guy here. That's going to be either a sine or a cos. Yep. Let's do sine because it's a positive, equals, take that 2 out, don't like that, 1 on square root of 9 minus x squared. Now, what form is that close to? I'm straight to it. A squared minus x squared sine x on 3 equals 2 sine inverse x on 3 plus c. X on 3 plus c. And there we have it. 2 sine inverse x on 3 plus c. Coming over these two over here, this is going to be a tan, and we're looking again at this form here. I want the derivative on top, and I want 1 plus squared. So that's exactly in that form, nearly. If f of x down the bottom here, let's go, well, if f of x equals e to the 2x dash x be, f dash x would just be 2e to the 2x, 2e to the 2x. Okay, so I want that 2e to the 2x on top. 2, I'll pop out a half out the front, and then I can jump straight to my answer, which is a half tan inverse e to the 2x. And I've got my little plus c just down there. This last question here, it's going to look like a sine or a cos. Again, I want, which is up here, I want that f dash x on top. Alright, I can do a substitution, but I'm not going to write all that out because I know I just want it in that form. We'll do, well, if we got here, if we've got f of x equals, I want that is the f of x squared. So that's x squared squared. Yep, so f of x equals, so f of x equals x squared. That means f dash x equals 2x. So I want a 2 there, a half there, and then I get equals a half sine inverse x squared plus c. Okay. Do it in a couple of different ways. You'll see why soon. Differentiate this, hence find the primitive of inverse sine. Now we haven't been able to find the primitive of inverse sine. We've been able to find the primitive of these weird looking kind of functions. Okay, so now what I want to be able to do is to integrate inverse sine, which is awfully exciting. Let's go. D by dx of x sine inverse x using the product rule is going to be hold one, differentiate the other. So I've got x by the derivative of that guy is 1 minus x squared. And then I want to add that onto old one and differentiate the other. Sine inverse x. Okay, so I've got this. I want to find the integral of that. The derivative of this is this. So the integral of this is this. So the integral of the right-hand side, so the integral, and I'm going to split this, okay? I'm going to say the integral of that plus the integral of that, just to save a little bit. X on square root of 1 minus x squared dx plus the integral of that guy dx equals x sine inverse x. Oakley dokley. Now what I want is this one. That's what I want. So I'm going to subtract this one over to the other side. So taking it over to the other side, I'm going to isolate that integral. The integral of sine inverse x equals x sine inverse x minus the integral of x on 1 minus x squared dx. Okay, equals x sine inverse x, and then I'm going to subtract the integral of, let's call it x, and then we'll go 1 minus 2x to the 1 minus x squared, 1 minus x squared to the minus a half. Now this is just my, what did we call it? Kind of reverse chain rule. Sorry, lagging. Alright, the derivative of that is minus 2x. So I'm going to put a minus 2x out the front there. I'm going to go plus, that's going to be, well, I want that to be a minus 2, don't I? So I put a minus out there, and then I put a half. Okay with that? Then I get equals x sine minus 1x plus a half, and this was just a function with the derivative sitting out the front, so that's just 1 minus x squared to the half, because I added a 1 to minus a half, and then it's also divided by a half, divided by a half. Now, just zoom out a little bit there. Now those halves will cancel, and I will get equals x sine inverse x plus 1 minus x squared, sorry, a bit messy, to the half, okay? And that is going to be my answer. Equals x sine inverse x plus the square root of 1 minus x squared, if you would prefer it like that. Here obviously I've got a plus c. Okay, I've got a plus c here. But that's going to lead me on to b. Okay, so what I want to do in b is I want to find the shaded area under the curve from 0 to 1. So I'll just do b in one go. I won't write it all out again. I'll get rid of that. Okay, so we'll get rid of that c. And so for part b, I'm just going to do that in orange here. I'm just going to put on my bounds from 1 to 0. And that's essentially just finding the area under the curve, isn't it? Great. Equals, chuck in 1, and I get 1 sine inverse of 1 plus, chuck 1 in here, and you get 0. Subtract 0, because I put the 0 in here, plus square root of 1. Now, which angle gives me a sine of 1? If I think of my way back to my graphs, which I'm going to use in a second anyway, to get 1, I'm at pi on 2 equals pi on 2 minus 1. Pi on 2 minus 1. Here we go, there's a 1 there. There we go. Pi on 2 minus 1, what's that? 3 and a bit. 1.5 minus 1, 0.5-ish. Okay. Now, we're going to do it another way. I should have drawn this out before. Okay, I should have said, okay, I want to find the area under, what did we say? Area under sine inverse x, which we know looks like, well, that's 1, isn't it? And that is pi on 2. So it's asking me to find this area here. Alright, and from my answer below, it's told me that this bit is pi on 2 minus 1. That's what I found. I want to do it a different way now, without, just by thinking. Okay, just by thinking about it, by thinking cleverly about it, I guess. Just using areas and looking on, turning your head on its side there. Okay, I'm going to draw this out. I want this guy. I want this guy. Okay, I want this shaded area there. I can get that by finding, well, so that's what I want. I want to find that area there by minusing off, find the whole rectangle and take off that bit. Okay, this whole rectangle, what's that whole rectangle? Well, it's 1 by pi on 2. Pi on 2. What is this area here, that shaded bit? Well, if I turn that on its side, that's just the same as, that's sine inverse. So we're looking at this bit here. Now, if I turn that on its side here, I would go, well, that's just, and the area under this bit is a lot easier to do because I know I'm going from pi on 2, 1, and so that is going to be, we got the integral from 0 to pi on 2 of just normal sine x. Yeah, of just normal sine x dx. The integral of sine x is just, well, it's the minus cos x, isn't it? Good. Yes, so I get, well, that's pi on 2 minus cos x, which is from pi on 2 to 0. Cos of pi on 2 is 0 equals pi on 2 plus 0. Cos of 0 is 1. So I get that minus 1. There we go, which equals pi on 2 minus 1. Oh my god, it's the same thing. So, guys, I've got two solutions there, pi on 2 minus 1. This one is done rather simply, isn't it, on the right hand side? This one, you're kind of bashing it out using integration, whatever. Do it both ways and give it a good practice. Alright, ciao.